This is section 3.3, slope of a line. In this section, and actually for the rest of chapter 3, we are going to be getting several formulas. You really do want to know these. If you were taking a test in class, then I would have you memorize them. If you're taking an online class, I recognize that there are ways you can get away with not memorizing these. I'm just going to warn you that memorizing them now will help you out a lot in future classes. These formulas do not go away. You will be using them all the way through college algebra and further if you go further. Okay, so the first definition for slope. First of all, we use the letter M for slope. I've been told this comes from the French word for slope. I've never looked it up, so I'm not positive that's true. Okay, so what we've got here is we've got 3 different definitions of a slope. They're all technically saying the same thing. We kind of use them in different scenarios though. The first definition is the change in y over the change in x. This is a ratio. How much, compare this to this, okay? How much is your y value changing over how much your x value is changing? This definition is more for understanding. Okay? Then we have the rise over run definition. This is one that people tend to remember long after they remember what it's actually used for, rise over run. This is another way of saying this because your y value would be up and down because y's go up and down. Over run means your left, right, which is how much your x is changing. We use rise over run when we're using a graph most often. Either when you have a graph and you're trying to find the slope from the graph, or if you have the slope and you're trying to use the slope to create a graph, we tend to use rise over run in that situation. Now this one, y2 minus y1 over x2 minus x1. You use this one when you're given 2 points. Okay, and those 2 points would be x1, y1, and x2, y2. This is an and sign, it's not some funky plus sign. Okay, this is just saying you subtract your y values, which would be how much your y is changing, over you subtract your x values, and that's how much your change, that's your change in x. So these are really all saying the same thing. It just depends on what it is you're trying to use your slope for. Okay, so kind of what's another way of understanding what a slope is saying? It's a way of discussing this is my definition, the steepness of a line. It's how we quantify the difference between a line that goes like this and a line that goes like this. Okay, we're going to have a numerical value. That's what a slope is. A slope is always a number where you talk about the difference between these two things. Okay, a couple things I want to point out here. We never change a slope to a decimal. That's hard to read, D-E-C-I-M-A-L. All right, never change it to a decimal. This is a ratio, and remember with ratios, it's a comparison of one thing to another. If you change it to a decimal, you lose that comparison. And for similar reasons, we never change to a mixed number. We also lose that comparison. Okay, reduce your fraction. That's a rule pretty much in any case anyway. And I'm going to point out one more thing. There is one difference between a ratio and a slope. There is one thing we are allowed to do for a slope that we're not allowed to do for a ratio. We can drop a 1 in the denominator. Now, what I mean by that is if you do your calculations and you end up with 3 over 1, we are allowed to change that to a simple 3. When we're doing ratios in general, we have to keep the 1 in the denominator for the comparisons aspect, but this is the one exception for a slope. Okay, so I know that eventually you're going to have access to graphing calculators. You're going to learn how to use them. One of my goals in teaching you graphing, the first one I've mentioned a couple of times, is that graphs have meaning. The second is I'm going to be teaching you a lot of things that you will be able to just look at your equation, look at your graph, and have an idea of whether you are correct or not. It is incredibly easy to enter something into a calculator incorrectly. And there are ways you will be able to spot certain mistakes very, very quickly if you just think about it a little bit. And one of the things we can look at is the sign of your slope. Now, these are positive, these are numbers. You will get a numerical value here. So you can have a positive number, you could have a negative number. 0 is technically not positive or negative, so we'll talk about this. And then it is possible also that you get something that is undefined. If your x values are the same, you're going to end up with 0 in the denominator, which would give us something that's undefined. So if we have a positive slope, one thing that we know, no matter what, is that when you look at your graph, going from left to right, your graph will go up. Now, I don't necessarily know where it is. I don't know if it looks like this or if it's steeper. Okay, it doesn't matter. You know, my sign tells me that it goes up. Just for reference, the flatter your line, the smaller the number, the steeper the line, the bigger the number. Okay? If your sign on the slope is negative, your graph is going to go down when you look at it from left to right. Again, we don't know from the sign alone how steep it goes. I mean, it could be going down very, very, very quickly. Or it might be going down very, very slowly. But what I do know is that it's going down. Okay. Now, if your slope is 0, then you have a horizontal line. Okay? If you think about this, you can see why. Remember, if we have a horizontal line, it has the formula y equals some number. Well, that means you have your y value on all of your ordered pairs on this line are the same. So you would have 1, 4. Just imagine that it's y equals 4. Okay? 1, 4, 2, 4, 3, 4. All of these would be on the same line. And if you think about plugging into your formula, when you subtract your y values, you would get a 0 in the top. Okay, so I'm helping you make some connections with what we've done in the past. Similar thing happens with undefined. If you end up with a 0 in the denominator, then you have a vertical line. Okay, and the same type of thing is happening here as here. It's just, in this case, all of your x's are the same instead of all your y's being the same. Okay, you will be able eventually to look at an equation and tell the slope immediately. And if you keep just this part in mind, you'll catch a lot of mistakes.